Hey, what is up, everyone? So welcome back. It's been a minute, but let's go over what we're gonna do in this video. So over here we have a little chat application. So I have two tabs open over here. One is t.code and the other one is John Doe, and we can start sending chat messages. So if I say, "Hi, my name is John," I send that over there, and over here on t.code you can see it. And if I even split it up into these two different screens, which would probably be better, I can just say, "Hey, what's up?" And over on the right you can see the person that sent it, and you can add more tabs too. So everything here is through gRPC, React, and Redis. So if you're really interested, let's move on. So welcome back. So I just want to go over like the overall architecture of like how this whole app is gonna come into being. So over here on the left we have like a high level overview of the different components that play into this. So we have gRPC, and we want our gRPC server to be communicated by with a React app. And now it's not currently easy to talk to a gRPC server directly from your browser. There's things you got to do. So because of that, there's an Envoy proxy that's going to be in between, that's going to be relaying messages back and forth between the gRPC server and the React client. So we have our React client over here is talking to our Envoy server, and Envoy server is going to be talking to our gRPC protobuf, and then it's going to be storing whatever messages and user information to our Redis database. So the way we're architecting this is also that we can scale our different servers out. So we have one stateful Redis database at the top that's going to keep all our information, and that way all the servers are in sync. It's not that we're keeping all the messages in our server, and that's sort of acting as our stateful server, which isn't good. Like, can't really scale out, and the messages, one server doesn't know about the messages of the other that easily, so it's best to attach some sort of database layer. So I chose Redis. Over here at the bottom, Redis relies on key value stores. So the keys are, there's a syntactic best practice about how to leverage these keys. So just looking it up, the best way was to have a keys for the room 0, where the room 0 would be the main room. So we're only worried about the broadcasting room. We aren't really going to be making user-to-user communication, even though that's also pretty easy. But I think if you know broadcasting, you know user-to-user communication. It should be easy. So it's a general room for all the messages. So every user will store their message in there, and all the other clients will consume also from that. That key value store will be a list. So whenever a new user inserts a message into that key, it's stored as a list, so it will be ordered by default, which is great, right? So we can get the chat messages in the default order that we put them in. And what's great about Redis is that it is ACID compliant, so we won't have any sort of race conditions and stuff like that. So it's going to wait until the message is in, and then another one will get inserted right after that. So there won't be any race conditions of that sort. Yeah, so we're not implementing in a direct user-to-user communication. Even though that's pretty simple, you would generally have to just make more room keys, and the rooms would be associated with those specific users. So just something to keep an eye out for. So this is the workflow to joining a chat room. So we have a user 1 who's going to send an initiate chat request. The user then gets saved on the database, or Redis in this case, and then it sends back a user ID, and it says, "Hey, for whatever communications you do to us, just send the user ID so we know who you are." So there's going to be a user stream. So we're gonna leverage streams to help us get our real-time chat application. We could poll the server, but that just overcomplicates things and it's not as efficient. So we're going to use streams. So we're going to use a user stream, which is going to stream us the list of users that have left or joined the chat room. And then we're also going to have a chat stream. Now that chat stream is going to tell us what new messages have come on the Redis list, and it's going to send it to us. And then when the user stream and the chat stream cancel, then that signals an offline request. So then we're going to send an offline message to all the other users. So this is the open connection that we're going to be sending data back. So users leaving the chat room over here. So user 1 goes to the user stream. They disconnect from both the user stream and the chat stream. It marks user 1 offline and cleans up any streaming resources that are stored on the server. And then we send a broadcast to other users that they are offline over there. So that's generally the high level overview of how we're going to build this. That's really quick, really short. Now let's just dive right into the code. Okay, so one thing to note is that we are going to reuse our past TypeScript node gRPC server. So I have a video made previously about how to create it from scratch. So if you don't know how to do that, definitely go watch that video. But this is the repo over here. So if you go to Floyd Jones 1 TS node gRPC, you reach my code over here. And there's also a video link that takes you to the video if you want to watch it. Otherwise, you can just follow these steps and you can generally get up and running pretty fast. All right, so let's open up VS Code because I actually need this code over here. Pretty much I'm going to reuse it. So over here we have a React gRPC folder that I made. So I'm just going to do a git clone and then put a dot over here. The period means just I don't want to make a new folder. I just want to paste everything in here. So we have a proto file over here, which has our proto definitions that we've used from our last example. We have our client.ts over here. So we're actually going to delete this. We don't need this. So our client is going to be the web, is going to be React now. So we don't need that anymore. We will be needing this, we will be needing this, and we will be needing this. Okay, so let's do a yarn install, get all our dependencies. And now let's also get our React app. So let's make directory client, cd into client, and npx create React app -- template TypeScript. And then I want to, actually I want to do this outside, right? Because React makes a folder by default. So I want to cd .. rm client, right? rf, and then I just want to npx. Let's Google, look that up like good developers. So create React app over here, create React app, and then npx create React app over here. So let me paste that in over here and just do -- template is TypeScript over here. So this actually sets our entire application up for React. And the reason why we're using create React app and not Vite, which I promote more than create React app, is because we actually can't use ES6 module imports with our gRPC stuff. So the gRPC client that we're going to be using is not completely stable with ES modules. So we got to use the require syntax. And the thing with Vite is that Vite's like, let's not move backwards, let's move forward into the future and use ES modules only, so I can't use it over there. So unfortunately, I have to use this. I say unfortunately because I don't necessarily like create React app too much, but that's a different story. All right, so let's do a yarn install over here because we already have that ready. So if we do a yarn start, we should get our create React app up over here. We can open this up and see if everything is up to our standard. Everything is TypeScript, which is exactly what I like over here. Something seems to be running on another port, but that's fine. One of the reasons why I don't like it is because it goes a bit slow, but let's see what we have over here. Starting development server. Okay, so we got that up, and possibly this is up and running over here. Let's start now by cleaning things up. So let's actually stick to our server code for a little bit. Okay, so now let's just delete all of these. We don't need this. We're gonna call this service chat service, and over here I need to just delete all of the messages just so I'm not confused with anything. So now over here I'll just do RPC method, and I'm just gonna name this initiate client. So over here RPC chat initiate, and it's going to initiate request and return and initiate response. Right? That's really all I need for this. Returns over here. So now we got our chat initiate. We also need our RPC unary call to send messages. So send message, and over here will be a message request, and it honestly it doesn't need to return anything. There's no value for it, so I'm just going to import Google buff.empty. So this just means I'm sending an empty response back, and then we need two more. So RPC user stream, right? So it'll be a stream request, and then we're gonna returns a user stream, a user stream response. Okay, so one thing over here, since it's a stream, if you remember from our last video, we do need to put a keyword stream over here so that when gRPC does its generation of the code, it actually supports that. So another thing we finally need is a chat stream. So chat stream over here, and again it'll be a stream request, because the first request that you always make to the streaming is always going to be a request to sort of open that tunnel. So we're going to return another stream over here, and it'll be stream message, right? Yeah, so it's going to be stream of messages, but I'll just put message because the stream is plural by default. Okay, so now let's make our different messages, right? Like, where is all this coming from? We actually need to generate it. So let's go over here and say message initiate request. So in the initiate request, I want the user's name. So string name is equal to 1. And I also need a avatar, so like a profile photo. So I'll say avatar URL, and that's just equal to 2, right? And then we have our initiate response. So over here, we need to send back sort of a unique ID for this user. So I'll say int. It'll be int32, and it'll be an ID is equal to 1. That's all we need. So now let's move on to our message request. So this is what's going to be sent. A user's going to send their message, and that's going to get broadcasted to all users. So message is equal to message request, and it's just simply going to take an int32 with the user's ID, right? We're going to be passing that for most requests. And it's going to just simply be a message, right? Message is equal to 2 over here. So we have message request. So this is going to be empty over here, so we don't need to have to fill that up anywhere. And now we can focus on the user stream. So over here, I just fixed that typo. So message user stream request user stream request. So this is just going to be simply the ID. It's just going to initiate that request. And then the user stream response over here is going to be the list of users. So it's just going to be a array. So repeated users equal to 1. So we're just going to send out all our users whenever there's a change. That might not be the most efficient way in the long term, but this definitely works right now. So now let's create that specific user case, right? So it is a message of a user, right? And that object is going to have an int 32 for the ID. And then it's going to have a bunch of strings over here. So string name is equal to 2. String status. Actually, status is going to be an enum, but I'll just keep that as a string for now. And then finally, a string avatar URL is equal to 4. Okay. So again, I said status will be an enum for whether they are online or offline. So to create enums, I'll just do enum status is unknown is equal to 1, online is equal to 2, and offline is equal to 3. So that's what we're going to use for our status stuff. And finally, what else do we need, right? What else do we need? We got our response over here. So we need our message stream. So this one is interesting, right? So in this case, I'm going to be sending only one of the most latest request out as compared to the user stream, because this can get fairly large, right? Everyone is sending in requests. Whereas for a user, it's only going to be as large as how many users are in. So it's totally safe right now. So int32 is equal to ID. That's equal to 1. We need the message. So that'll be a string message is equal to 2. We have another string over here, which will be, actually that should be fine because we can derive the user from the ID, and then we can attach whatever we need and send them the message. Okay, so now let's save that. One thing we need to do is to import Google's own empty proto stuff over here so we can use it over here. So that removes that error. Do we have any other errors? We have this is equal to 1, and that is because enum start from 0, right? Something like that. Unknown is equal to, I'll figure that out. Okay, there we go. So it's fixed. Okay, so now we need to run our generator. Like we don't have the same thing we used last time, so we don't need that anymore. Let's go to our server over here and actually let's see this all break, right? So let's do a generate. I'm pretty sure I have a generate script over here. Yarn proto gen. And this will succeed mainly if there isn't any errors, and it seemed like there weren't any errors. Okay, everything went through smoothly, right? The proto file generated all of our chat service, all that fun stuff. I should actually make a script to clean up everything and then regenerate everything, because now we have these danglers over here, but we can clean that up later. That's no problem. So now let's go to our server and we'll see TypeScript just complain and be like, oh my god, what is this? This is ugly. So this is really cool, right? Because you want to see what you've done wrong. If you didn't have TypeScript, you wouldn't know what you're doing wrong over here. So this is actually really beautiful. Okay, so it's not random handlers anymore. It's going to be, so we don't have a random package. So over here we're going into random package, and then we are reaching into our chat service over here, and it's going to be our chat service handlers over here. So I'm going to use that to type everything over here, so I should get nice typing. Over here it's going to say that random doesn't exist, is because I changed it now to chat service. So that fixes that, and now we can start defining our handlers. So Let's just do our Unary stuff, and then we will move on after that. So, what was the name of that? So we named it chat initiate, right? So chat, we get that nice IntelliSense kicking in because of TypeScript. So the Unary call passes in two. It's going to pass in a call, which is basically the request, and our callback, which is something we can use to send data back. So over here, we're going to do some very simple validation. So we're just going to do const session name is equal to call dot request, right? Request dot name over here, dot name, or it's an empty string, because you can sort of get away with this. If you send a request, you can not send in anything, and this will be undefined, so I'll just default that. And then the other one we have is avatar URL, and again, we will empty that out. Over here, I'll just name it avatar over here. So we have that in, and pretty much we're just going to be like, if there is no session name, or there is no avatar, then I just want to return an error. So call back over here, and I want to return a new error saying name and avatar required, right? That should be about it. And over here, I'll just return so the function stops executing. All right, so we have this basic setup over here. Let's delete this right now. We also will need this eventually, so I'm going to just comment that out for now. And yeah, let's just delete all of this, just so we don't get any fluff. All right, so let's first try to prove that this works and tries to communicate with our client. I think that's the most important part. So at the very end, we will just say callback. If there is like a username and password, then we're going to call back, and we're going to send a null error saying that there's no errors, and we need to send an ID back, right? That's what we promised. That's what we promised to send back. So we'll do math.floor, math.random. Over here, this is just going to be a very simple thing. So I'll just increase it to 10,000 over there, and so I'll send a callback over here. So another thing is that let's just modify the script a little bit so it's cleaner, because this is actually annoying me. So let's just do rm rf and then random dot slash proto slash random package over there, and then we will generate. So now if we do yarn proto gen, it cleans that out really nicely, and then it generates us our brand new stuff with just what we need. So now let's we need to generate the same thing for our React app, right? So let's do that. One thing to note is that we do need a couple things to make a React sort of communicate with it. So let's go to our package.json over here and get a few things that we will be needing. So a few things we will be needing. So we'll be doing yarn add gRPC web. And again, you can look up all these packages and see what they do. We will need Google Proto buff and gRPC web, Google Proto buff, and pretty much that is it for all our main dependencies. Like, that's pretty much it to make things work, which is actually pretty cool. Let's see, we need any types? No, we don't. No types needed yet. So let me just yarn add this into our application. Another thing is that a prerequisite is that we also need Docker. So to make Envoy work and to make Redis work, we need Docker. So let's create our Docker image to try to make things work. But before that, let's actually make that promise and actually generate our TypeScript, our client for React to use. So we'll make another generate file over here. We'll just do, actually, I'll just drop it in here because Yeah, because it's the same exact thing. So I'm not going to write everything down because this is actually very verbose. So I'll just copy this and paste it in here. So essentially, I will go into my app over here, go into the source folder, and then go into the Proto folder over here. So in this case, I don't have one, so it's going to make one. If it doesn't exist, it's going to use the Proto compiler to compile our Proto. So the place it looks for, it's in here. So it goes into our Proto on the main file and it generates whatever things start with Proto. But this just won't work out of the box, right? So let's do yarn proto gen, right? So it's going to execute that, and then it's going to try to, okay, so it didn't really execute that because, did I save it? Let me try again. Interesting. Okay, so let's just make a new one called Proto Client.sh. And over here, I'll just copy this over. So let me bring this over here and then do Proto Client client.sh. No such file or directory. Where am I? Proto client.sh. Oh, okay, it can't find the client source folder. So, yeah, that's a fair thing because I forgot to name that over here. So it's like, what's going on? So no such file or directory client. Okay, I need to change all the references over here. So this worked fine. It's because I already have Proto compiler already installed on my machine. So that's the only difference, right? So if I say which Proto C, I can see I downloaded it through Chocolatey. So Chocolatey is really great. If you're on Mac, you would have to use brew install to get Proto C. If you're on Windows, I highly recommend you use Chocolatey to get it because it already gets it into your path variables and stuff like that. Okay, so anyways, if you need Chocolatey, just go Proto C Chocolatey, right? And then you will get the first link over here. It brings you to Chocolatey. So all you would have to do is say Choco install Protoc, and that will get you your latest Proto C compiler on you. So let's forget about that. I was trying to prove that if you remove it, it definitely doesn't break. It definitely breaks, but you can test it out on your own. That definitely works. So now let's see what we generated. So let's go to our app, go to our source, go to our Proto C, and we have a few generated clients over here, which is actually pretty nice straight out of the box. You get a bunch of TypeScript definitions over here, which is really great. So let's use it, right? Let's go over here and let's leave this exactly the way it is. And let's do a use effect. I want to on mount, I want to make a request to my client, and let's see how it works, right? Okay, so use effect, use effect. Okay, I thought it would help me out, but it's not. Oh my god, I need a pilot. Okay, so use effect over here just takes a function, and to say that it has to run on mount, I will give it an empty dependency array list. So now everything that I need is pretty much inside my Proto C folder over there. It's already generated and ready for me. So all I have to do is reach into there. So right below over here, I'm just going to say import, where is it? So import, and I'm just going to destructure everything from proto / random pb. The other thing is just TypeScript definitions over here. This is the client specifically, so actually let's get in the client right now. So I'll just copy this down over here. And yeah, so let's get in the client. So / protobuf client, and over here it's just random. Sorry, no, it's a chat service client. So over here, this generates the client for you, which is actually really, really nice. So since this runs only once, I'm just going to generate my client on the inside. So const client is equal to new chat service. And what this just takes is the endpoint to where the chat service is. So I'll say http :// local host. What host was that on? So if I say yarn start over here, this might not even load up because there might be things missing, but actually over here. So 8082 over here. So that is our client. And now all I would have to do with the client would just be like client dot see, we have everything ready for us right here, which is actually really nice. All our handlers just ready to go. So chat initiate over here, it's going to take an initiate request. So let's bring that in over here. So that's going to be our initiate request over here. You'll say const request is equal to new initiate request, and I can just do request dot set name, and the name will be t.code, and then request dot set avatar, and I don't really have a link right now, so I'll just do that. So now all I have to do is pass in my request over here, and then that's pretty much it, right? So we need to do that, and then it also takes a metadata field, so we're just going to pass that as an empty object. And what's interesting is that it says it's a promise, which is really cool. I haven't noticed that, but I guess this is a promise, so you can await this. Okay, so let's do that, right? But I need an async function, so I'll do async. I'll do an immediately it invokes self-executing function over here, just so it runs immediately, and now I can just say const response is equal to await, and that should be it. Yeah, so let's see over here, expected 0 arguments. Oh, okay, I need to say set avatar over here. So now chat initiate request over here, and it returns a promise, which is actually really nice. The last time I did this, it wasn't a promise, it was a callback. So I mean, hey, you learn something new every day. So now all I'll do here is just console log. Also, this will return a error. So what I'll do is I'll just handle the error over here. I'll just say console error over here, and then I'll just console log response. I actually prefer async awaits anyway, so this is actually beautiful. Okay, so let's do our yarn start. We got our server up, we got our yarn our server up, and now we'll just boot up our client. We have everything we need, and in theory, this should work, right? We're saying, oh, we got everything, right? We communicated with our server, we just don't have our proxy. So let's see how this gets handled over here. So again, create React app. I'm probably going to be roasting in this entire video. Facebook will never hire me. So no expected assignment or function call, some ESLint stuff over here. On line 9. So on line 9, oh, okay, so it didn't really, okay, yeah, so that makes sense, okay, right? That should work. It tried to clean things up before. Let's see what we have over here. So failed to initiate chat request. Yeah, so this is failing over here. So our next order of business is to try to get this to work, right? There seems to be some issues over here. This is the request headers, and we didn't really get a response. Seems like there's fail, what does it say? Fail invalid HTTP response. So the response the browser is getting is invalid. Like it's pretty much invalid. So it's not handling it well. What I'm curious about is that if it even reaches here. So I'll just do console log session name. I'll just say hey. You know what? It'll make it easier. So I will say hey over here. Cancel that. Start it. and let's see what happens. So the port started, I refresh this over here, and yeah, so it doesn't really reach here, unfortunately, but let's fix that up right now. So as I said, we need a Envoy proxy in between our server and our client to get things to communicate. So that requires a little YAML configuration. So what we're going to do, I'll stop the server, stop the client, and I'll just touch an envoy.yaml file over here. And inside here, I'm going to paste in some configurations. Again, I'm not going to be spending my time over here, so I got something all up and ready. So I'm just going to go over this real quick. Most proxies have like an admin port that you can go visit. So over here, it's setting up an admin port for 9901, and that's where you can access all the logs as to how the requests are handling, any failures, so on and so forth. So this is where the important part is. So there is a listener, and we name it 02, and it listens to port 8080, right? We're just listening to port 8080 over here, and that's where all the communication will generally happen. So it attaches all this filter chains over here. It checks for specific prefix matching. So over here it just says, well, to all, just send it to echo service. Let's just change this to chat service over here, so it's actually more descriptive. As a timeout of 0, max stream duration is also 0. The stream can stay open for as long as possible. It might depend on your requirements, but in this case, I'll just leave it to 0. And any request over here, there's a max age, custom header, and there's a bunch of HTTP filters over here. So now we have our main thing, which is our cluster, right? So Envoy is right in between the client and the server. So it needs to know of all the services in the background. So it's going to point to our chat service over here. It's going to point to our chat service over here and expose it to 9090 over here. So a couple things to mention is that we have to match up the ports because we don't see 8082 anywhere. So we're just going to copy this port value and actually paste it over here because this is the port for this cluster over here. So it's going to forward it to this port over here, and it's just going to be listening. This Envoy server is just going to be listening on port 8080. So that's where we're going to be doing all the communication. So the client will only know of port 8080, but Envoy proxy will know of the gRPC server in the backend. Okay, so this is literally all we need because now we just have to make a Docker setup. So again, over here, our Docker compose, I'm just going to paste this over here and explain what's going on. So we're just going to be mapping ports over here. If you ever used Docker before, you know, this is how you map ports. And we're also going to map volumes. So our Envoy YAML that we created, we also want to map it to the internal. So this is the external and this is the internal over here. It's going to map it to this inside the Docker container. We're also going to get Redis. So Redis over here, we're going to have a sort of like a stateful Redis over here where it maps to our file system. So over here, I'm just going to create a folder. I'll just call it Redis for now, and I'll change this to Redis as well. And yeah, that's about it. So you can actually look all of this up if you go to Docker Envoy image over here. The first link will be this. So you can see this is actually directly the Envoy's website, but you can use this right over here. So you can just copy this and use this if you want. I'm pretty sure I have a different hash because I picked a newer version of Docker. Let me see, E4955, and what do we have over here? FE something. Yeah, so I got a different one, but you can use this one as well. It's roughly the same thing, but you can go to Docker over here, Docker Hub, Envoy Proxy, and you should see a bunch of container images over here ready to use. So which one do I have? Envoy dev. Okay, so over here it was updated 2 hours ago, so you can go in here and actually pull this directly. Like you don't need to do anything, but if you do want to just use the exact same image, just so your setup is exactly the same as mine. So we have this set up now. Let's give this a shot. So it's listening to port 8080 and 9090. So this is where our client will talk to, and then Envoy will be like, okay, I'm listening to port 8080. What do you have to say? Well, forward all requests over here will match this, and it will go to our chat service. So then it'll look up our chat service over here, and then it'll go to our load balancer endpoints and be like, okay, so where do I gotta forward this to? Forward this to 8082, which is exactly where our server is. So our server is also on port 8082. So let's give this a shot, right? So just do docker compose up. I'm not gonna do it in detached mode right now, just to see if there's any logs that are coming out. Everything seems healthy. Yeah, so everything seems healthy over here. I'm just gonna split another window and just do a yarn start just to set up our server, and then I will do another yarn start over here to set up our React client once more. Let's inspect this to make sure we're not missing out on any of the fun. Open up the network panel just so we can see. Okay, so let's see what we have over here. Aha, so we totally forgot to change the port because it's still trying to reach to port 8082, but it's not there anymore, right? We got to talk to Envoy, and Envoy is on port 8080. Yeah, Envoy is on port 8080 over here because it's listening on that port. So we'll just take that and just plop it right over here. Save that. Go back over here, and over here we have a green light on the chat initiate, and if we go back over here we actually see we have a hey message over here. So we're getting our requests through, and if we notice the payload that's sent back, obviously that doesn't make sense because we're in the land of gRPC, so this is all compressed text, so it's much lighter weight. As you can see here, it's like 443 bytes. Not that the payload is pretty big right now, so it doesn't make sense. But the place that you can actually look at it is over here. So we console log the request, and we can see everything. Now this also doesn't make sense. So what we're going to do is just go here and say response, where is this? So, I want to go back to the callback method that I initially had. So it's actually two ways of doing this. Okay, so it could either be a callback or it could be a response. It just depends on your signature of your choice. So let's go back to the callback method of things. So over here, I'll just say error and response. And this is also typed stuff, so we are good. I can remove this because it's not a promise anymore. I'll remove this. And I just want to show you what message we're getting back. So console log response dot to object over here. So now we're getting nice IntelliSense, which is what we need. And yeah, so let's console log that. Let's go back over here and we see our ID now. So let's refresh this page. See, we got a different one, 7,993, 2,254, and so on and so forth. So we're seeing we're randomly generating numbers, which is what we need for the start of this. But yeah, this is basically a introduction setup. So how you can set up React with Envoy, with gRPC, and get everything up and running. So this video is running a bit too long. So what we're going to do is we're going to stop here and we're going to come back and finish off the rest of our chat app. So in this video, we've just gone over the introduction, how to set things up. Now we just have to configure the business logic to help us do our bi-directional communication. So I hope you enjoyed this video. If you did, please drop a comment down. Show some support, really goes a long way. And I'll see you in the next video. Peace.